Okay, now it's fine. Uh, Now, today we'll start with the SPADE data mining, sequence mining algorithm. Now, this sequence mining algorithm, which you have done in the last class, is we have done the GSP algorithm, and today we'll discuss the SPADE algorithm. Now, there is a difference between the working of the SPADE and the GSP, and this depends on the data set. Now, till now, the data set what we have been using the horizontal data set, where the data set is in the form of the transaction IDs, comma, the items we are going to purchase. That means it is in the form of TI, comma, I, where T is the transaction and I is the item sets. Okay. Now, but in the vertical database mining, what we are using a database in which we are given the items and the transactions. It is in that particular for that particular item. For example, if I take one item I1, it is in transaction say T1, T2, T5, T8. That means this type of database is called as a vertical database. Now, if I ask you how to convert a horizontal to a vertical database, it only requires one scan. It only requires one scan of the database, where you are going to check the horizontal database and read the transaction by transaction and keep on putting it in a vertical format. Okay, how will you do? It's so simple. You take the first transaction, suppose it contains I1, I2. Now you maintain all the transactions what are there, you maintain as a column in a vertical database mining. For example, the items are I1, I2, I3, I4, say I10, till I10. And I find that in T1 it occurs over there. Therefore, what I will do is in front of I1, I will write T1. So, secondly, if I say second item is say I5, below I5, just in front of I5, I will write the particular items, sorry, transactions. Okay. Now that means it is very simple to convert a horizontal database or to a vertical database. Now, what the SPADE algorithm is going to do, it is using a vertical database representation. That means it will be in the form of the items and the transactions. Okay. Now, for each symbol S, which is an element of sigma, and you know what is sigma? Sigma is a list of symbols we are going to use. We keep a set of tuples in the form of I, comma, pos of S. Now, how to keep that tuples? I means the items, comma, the position of that particular item or position of that particular symbol in that. Whereas that means when I will use the I, comma, pos of S, where pos of S is the set of positions in the database sequence SI, which is an element of D, and you know D is nothing but the database. Okay. Now, if that means for each and every the particular transactions, I will keep in the form of I, comma, pos of S. And if you remember, I was using this particular database. This one, where the sequences are S1, S2, S3, and the ID was S1, S2, S3, and the sequence was C, A, G, A, T, like this. Okay. Now you find that here this occurs over here. Now I will maintain the POS for this one. Okay. Now let L of S denote the set of such sequence positions. Tuples is in symbol S, which is called the position list. Okay. Now, what we are going to do is that we, for each and every symbol, we'll keep on maintaining the list of symbols at the position at which that symbol occurs. Okay. Now let us try to directly go to the algorithm and show you, because with the algorithm you will be very, very clear how I am going to do this. Now I'll just come back to this slide. Before let me just show you how it actually works. Now let us see this example. I am using, for A, I am putting 1, 2, 4, 5. Now what is 2, 4, 5? 2, 4, 5 is the position of A in the first sequence. Okay, let me show you that particular. Okay. Okay, I'll show you the particular both one together, which will be looking, which will be easier for you to understand. This I've combined together. See, you are having the sequences C A G double A G T. Now, at what position A is occurring? At position number 2, position number 4, and position number 5. Therefore, if this is occurring in this position, you are maintaining it as a 2, 4, 5, because it is appearing at position number 2, 4, 5. Similarly, if I find a sequence, I find a symbol A in sequence S2, I'll find it occurs at this position, 3rd and 5th. Therefore, I maintain it over here as 3, 5. Similarly, in the third sequence, it occurs at 2, 3. Therefore, it occurs at 2, 3. Therefore, I am going to maintain it. Sorry, I am going to maintain it as 2, 3. Similarly, I will do for other one, C, G, and T, and you know that there are only 4 symbols, C, A, and G, T. Therefore, I maintain the thing over there. Now, you must remember that I have used the minimum support that is equal to 3. Okay. Now, you see, A occurs in all the 3 transactions, G occurs in all the 3 transactions, and T occurs in all the 3 transactions. But C only occurs in 2 transactions. Therefore, any superset of C cannot be frequent. Why? Because if the support of C is 2, any superset of C will always have a support of less than or equal to 2. And this you must remember the property which is called as the anti-monotone property. This is called as the anti-monotone property. Now, using this concept, I know that from C, I cannot generate any frequent sequences. Therefore, I will drop C. And I will not develop any more future supersets of C. Okay, got it? Now, I am going to develop the extensions from A. Now, the extension of A will be AA, AG, and AT. Now, let us try to find for AA. Now, for AA, you find that the A occurs at position number 2, 4, 5. And therefore, it means that the first symbol is at position 2, the second is at position 4, and the third is position 5. Now, when I am maintaining the sequence for AA, I am going to only put the ending position. Did you get it? I am just going to put the ending position in the extensions of A. Extension of A meaning AA, AG, and AT. Now here you find that in S1, A is at second position. I am not bothered. A is at position number 4. That means the ending of this double A ends at 4. That means if I take the first one 2, 2 and 4 is one double A. And 2 and 5 is another double A. But I will not maintain 2 because if I just maintain the ending position. Now ending positions are 4, 5. Therefore, here I am putting it 4, 5. Because 4, 5 means I am going to put over there because of the fact that is the ending position of double A. Got it? Okay. Now, I take the second sequence. Now, where is double A? Of course, the first position is 3 and the second position is 5. I will maintain the ending position of double A. It is 5. Therefore, this will be 5. This will be 5. Fine? Okay. Now, for the third one, it is GAAGT. The ending position for this is 3. Therefore, I am maintaining it as a 3 over here. This is a 3. Now, similarly, I will try to develop for all. I will take AG. AG is having, you just check this over here. Now, here, you have to make sure that AG, G ends at 3 and also G ends at 6. Okay, if I take this one, you just see this one. If I take this AG over here, I find that G ends at 3 and G ends with 6, and A is, of course, it is before that. It is before that. Therefore, I'll maintain it as 3 comma 6 in the first sequence. In the second sequence, AG, G occurs at 6th position. You just check it out. G also comes at 2, but before that there is no A. There is no A. Therefore, G occurs at 6th position. Therefore, I will maintain it as here 2. The second one I will put as 2, 6. Similarly, for the third one, G comes at position number 4. Therefore, this will contain at position number 4. And similarly, you develop for all of them. For AT, where is T? T is at the position number 7. Here, at 7. Therefore, I will maintain at AT as 7. Now, when I maintain 7, it means that there is A before that, somewhere before that. But since I am trying to search AT, if I get T at the 7th position, A might be at 6th, 5, 4, 3, 2, 1, and that is immaterial. Why? Because I am not going to find the sequence for that T. Sorry, I am not going to find where actually A is there. I am just finding where is T, and if A occurs before T, it means that is a valid sequence. But here you find when I develop AT, I get only two transactions, and therefore it is not having the minimum support, and therefore AT will be deleted or it will not be considered because you cannot develop any further extensions of AT. Similarly, you do for GA, GG, GT, TA, and TT. Okay, and you are doing for all of them. Correct? Now, I could have also developed for TT, but you find there is no TT anywhere. Therefore, obviously, this should have also given you TT, because I am going to do it for T of with A, T with G, and T with T. But if you develop T of T, you find that there is no transactions for TT. Therefore, that is not going to come. And now, at the second level, you are going to remove all those transactions, all those subsequent sequences which are having a minimum threshold of less than 3. Therefore, AT will go, GT will go, TA will go, and TG will go. All these 4 will be removed. Now, let us try to find the extensions of AA. Now, AA will combine with AAA, AAG, and what? AAT. Okay, let me see if it works. AAT, fine, let us take. Now for AA, the AAA, what is the end position of A? The last A. Now you find that if in AA 4, 5 is coming, if it is 4, 5 it is coming, that means if I want to maintain for AAA, I will take the third A for this. The third A ending position is 1, 2, 3, 4, 5. This one. And for this one, the position is 5. Therefore, for AAA, it will come 1, 5. 1, 5. That for the 5. Similarly, for double AG, it will be 6, 6, and 4. See why it is 6? See, double A and G. Double A, 1A, second A and G. And this is 4. Therefore, I am going to get double AG. Similarly, I will do for AAT, I will get nothing. Okay. Because if I get also, I will not get equal to 3. Okay. Similarly, I will not develop anything with AT. I will develop for AG, I will develop AGG, AGA, and AGT. And I will develop all the extensions. Now, similarly, here AAA will be removed, AGA will be removed, AGG will be removed. And these 3 will be removed. Now you are remaining with only double AG, GA, and GAG. Now, with double AG, you can extend with only G. Now if I say with AAG, G it is not there. Therefore, I can only develop extension from GAA. GAA with GAAA and GAAG. Now GAAA is not there. Therefore, no further extension from GAA involving A can be developed. But GAAG is there. Now you find where is GAAG? It is like this. At the position number 6. Therefore, at this is position number 6. In the second one, it is GAAG is at position number 6. Therefore, it is also 6. And at S3, it is again at position number 4. Therefore, I am maintaining it equal to 4. And therefore, what remains is there. After this, I cannot develop any more extensions. Therefore, now what are the frequent items? Starting from the top, it is A, G, T, AA, AG, GA, GG, AAG, GAA, GAG and GAAG, because it is having a minimum support equal to 3. And all those which are not there will go off. There will be how many of them are developed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. There are 11 frequent sequences. Now obviously the first one is not important because it is having only single. Therefore actually it will only have a 1, 2, 3, 4, 5, 6, 7, 8 extensions. AA, now sorry, AA, then AG, GA, GG, then GAA, AAG, GAG, and then therefore it will have only 8 extensions. And if you see over here how many I have developed in the previous example, I'll just show you. How many of them are there? See, just check it out. How many of them are there? It contains 1, 2, 3, 4, 5, 6, 7 and 8. There are only 8 over here also. Therefore, the output which you get from either GSP or using the SPADE obviously will be same only. Okay. Now this is a basic algorithm, but let me come with the concept that how I am using the concept of finding those sequences from that how I am going to make it maintain the tables. So let us try to understand this and algorithm. Okay. Now when I am doing to do the support computation, I am using a sequential join operation. Okay. Now what I am going to do, I am having a position list of 2 K sequences. Say if I say RA and RB, that is going to share the same K-1 length prefix. Obviously, if they are having the same K-1 length prefix, then only I can use this. Therefore, I will perform a sequential join on the position list in order to compute the support of the new K+1 candidate key. That means with A, if I want to find for AA, I have to do a sequential join. Okay. Now, given the tuple in this form, we first check if there exists a tuple, that is, both sequences must occur in the same database sequence SI. Now, once I am going to do this, I check it out that whether both this one occurs in the same SI. SI means, say in this case, it is S1, S2, S3. Next, for each position P, which is an element of P of S of RB of K, where K is initially K is equal to 1, we check whether there exists a position Q, which is also a part of RA of K, such that Q less than P. What is the meaning of Q less than P? Q must occur after P. That means the position of Q should be after P. If yes, this means that the symbol RBK occurs after the last position of RA, and thus we retain it as a valid occurrence of R, AB. If Q is less than P, it means that it is not valid because that symbol is not coming after P. Okay. The position list will contain the RAB contain will comprise of all such valid sequences. And this is what I told you. We keep track of the positions only for the last symbol in the candidate sequence. And you know, I am only keeping the last sequence. Since we extend sequence from a common prefix, so there is no need to keep track of all the currents of the symbol. Why? Because if I am developing AAA, I am developing from AA. Therefore, obviously, double A is already there. I only want to maintain where is the third A. Where is the third A? Because I am developing with a common prefix of double A. And therefore, if I am using a common prefix of double A, I only have to find the last position of that particular symbol. Okay. Now this is the algorithm which we have just think. Though you don't need to remember this algorithm because there is no need to learn it by heart. But only thing is that I am applying with 4 parameters. Okay, I am applying with 4 parameters. Now here, if you check with this, I am going to this is the algorithm which I am going to do. And here, if you remember the last algorithm, here the GSP, I was doing it with D comma set of symbols, the mean support. Here I am doing it where P is the list. Okay, that means the position list. That means S comma L of S, which is the set of all the positions which is greater than or equal to mean support. Therefore, I start with P comma minimum support, comma that with the frequent items and with a K. Initially, F and K are both 0. Therefore, I start with P, which is the position list, comma mean support, comma F and K, which are both 0. Okay. Now you can just go with the algorithm. Now this algorithm is a recursive algorithm, and the algorithm looks to be very simple because this for loop is going to work. And there, when I find that I cannot develop a new extension, I am calling this again a SPADE with the parameter k plus 1. Because if I develop, say with A, I develop double A, AT, AG, AC, I develop all those. Then if I don't develop any more extensions, I call this with another. Now here, if you remember, if you see, here the parameter is P and here the parameter is PA because I am developing all the extensions of A. Similarly, I am developing all the extensions of G, all the extensions of T and so on. And therefore, this P will replace every time with one of the branches of that extension. The minimum support will not change. The minimum support will always be fixed. But the K will change because initially I start with K is equal to 0. Then I get K is equal to 1, K is equal to 2, K is equal to 3 and keep on doing until this algorithm will terminate that if I get that PA which is not equal to 0, then I will call that. If PA becomes 0, I cannot develop any more extensions. That means when I will call this algorithm recursively, if this value of PA over here is not equal to 0, this value is not equal to 0. If this becomes 0, it means that you cannot develop any more sequences, and therefore you stop at that point and try to find another A for this. Correct? Now this is the simple algorithm which is much simpler than the last one because it is working in a recursive manner, and you know that how the recursive manner, what you are going to do, you are just going to modify the parameters to call that algorithm. Obviously, all recursive algorithm must terminate to at the end. Then how will it terminate? When the value of PA becomes 0. When PA will become 0, the algorithm will terminate and you will not be able to generate any more future subsequences. Okay. Now this algorithm is given by Zaki and Zaki, and one of the very good algorithm because it is much faster. Why? Because in GSP, what you find, no, GSP is also good algorithm, but GSP, what you have to do is that you have to check for the database every time to find extensions. Whereas here you are using that algorithm and trying to develop one of the branches of this the tree. No, just you. What I expect you to just read this explanation, and with the database you just try to develop this. Now this is simple. I start with phi, which is null, and then I develop for the first one, then the second level, the third level, the fourth level, and can go to any level. But you cannot develop any more level because the fact that this is having only is only having GA. G is the maximum transition you can never develop. Okay. Now you think with this I complete this algorithm, the sequence mining. We have done only two algorithms, though there are lot many, but we expect to not cover all the algorithm. We just give you the basics that how it works, and depending on your requirement you can very well try to adapt any one of the algorithm. Now this algorithm sequence mining is used at many places. One of the very important places is the case of biomedical mining, where I am trying to take all the symptoms together, which are nothing but which are so for example, if I take some disease D1, and I am going to take the symptoms as say S1, S2, S3, S4, S5, and so on. Now I can maintain that for disease D1, the sequences, the symptoms are say S1, S4, S7. For disease D2, the symptoms are some other symptoms. And then I can only, if I get some sequences, I can track to find that whether this particular symptom are this sequence is for that particular disease, because I can very well say if suppose the symptom S1 occurs before S5, it means that it is the chances of that disease is there, because in that disease S1 occurs before S5 or S3. Okay, it can occur with any more of many of the diseases like say dengue. When a person has a fever, then followed by some rashes, then some platelets becoming less, and therefore first of all that fever will come. Therefore that could be symptom S1. Now in that case there could be a body rash. It could be say S2. It could be drop in the count of the platelets. It could be S3, and I can get that. Now if I get S1 S3 as symptoms in some sequence, I can try to check it out whether this relates to dengue or not. And therefore this is how you are going to apply the sequence mining. Okay, with this I finish this thing.